Okay, so this is our electricity knowledge test. Okay, now draw the following circuit components. Right now, I have seen questions where they literally ask you to draw one of these. All right, a cell is a big long line and a little line like that. A battery, what you do is you draw two cells, and then usually what you do is you kind of put three dots in between. A switch is a line like that, line like dot there, line like that, and line like that. So that's an open switch, and a closed switch would be like that. A lamp, circle with a cross. An ammeter, an A with an A. A voltmeter, a V with a circle on the outside of it. The diode, they're getting a little bit more complicated to draw now, right? So what I'm going to do is I'm going to start off with the diode. I'm going to draw a triangle like that with a line, and then what I'm going to do is I'm going to draw a line out, and I'm going to draw a circle around that like that. Right? A light emitting diode. So what I'm going to do now is I'm going to draw a triangle, a line. I'm going to draw a line out there, and I'm going to draw a circle. So what that does, that looks like the D for the diode. Now because it's light emitting, what you do is you do an arrow like that, and you do an arrow like that. Now I'm just going to skip past light dependent resistor, right? And what I'm going to do is I'm going to draw a resistor. So I'm going to draw a resistor. Okay, that is supposed to be a perfect rectangle. That's a resistor, and all it is just like a box with two lines coming out of it. Then we've got a light dependent resistor. So I'm going to draw my resistor, right? And then what I'm going to do then is I'm going to draw a circle around it. And because it's light dependent, right, what you're doing this time is you're drawing arrows onto it. A variable resistor, I'm going to do this one now. Again, it's got the name resistor in it, so I know, I'll go back to my orange, I know there is going to be a resistor in it. And this time, the variable resistor shows like that. A thermistor sounds like resistor again, and it is. So what I've got is I've got my rectangle, which is my resistor, right? And this time, right, what colour shall I do? I'll do it purple. This time, what you've got is a thermistor, and it looks like a bit like, oh, that's a very bad. It looks like an ice hockey stick that then goes through it. And the final one is a fuse, which again looks like a resistor, but instead the line goes all the way through. It's not wobbly, right? It's actually a straight line. Right, so how does current, voltage and resistance change between a series and parallel circuit? So what I'm going to do to start off with is I'm going to draw a bulb and a bulb like that. And a series circuit is where the electricity can only flow in one direction. That looks like a terrible car, right? It can only flow in one direction. So it's just got one loop that it can kind of go around. A parallel circuit, if I then draw in another bulb, and what I'll do is I'll just draw another wire in a different colour. It can go down there and it can go down there. So now what can happen is electricity can come out of there and it can go that way and it can go that way. Now, current in a series circuit always stays the same, right? Because the current, it's a bit like water, it can only pass through one thing. Voltage in a series circuit is shared. And resistance, what you do is you add them up. Because what you can actually get is you can actually get, let's say it's 3 ohms in a series circuit plus 6 ohms plus 5 ohms. You add them up, right, 14 ohms. In a parallel circuit, the current is shared. Sometimes I might even write down split. The voltage in a parallel circuit stays the same. Okay, so if I've got on this diagram here, if I've got 6 volts there, right, then what it is, it stays the same in each one of the loops. Resistance for this one is a little bit more complicated in the fact that the resistance in a parallel circuit is sometimes called less than the smallest, All right, so if you've got, let's say you've got 2 ohms, 3 ohms and 7 ohms, the resistance in a parallel circuit is less than the 2 ohms. But it can also be written, I'm just going to do it down here, the resistance total equals, so 1 over the resistance total equals 1 over resistance 1 add 1 over resistance 2 add 1 over resistance 3. Right, but I've got to be honest, the best way of actually talking about this is it's less than the smallest. So what are current, potential difference and charge? Current is basically the flow of charged particles, often electrons, but I like the word flow. Measured in amps. Potential difference is the energy transferred between 2 points, measured in volts. Resistance is the opposition to the flow of charge, and that is measured in ohms, which kind of looks like a bit like a funny hat. Question number 5. How are ammeters and voltmeters set up in circuits? Ammeters are always set up in series. So if you're going to do one, what you're going to do is you've got a bulb there and you've got a bulb there. Okay, there's your circuit. An ammeter would go in there, right, because it's in series within the circuit itself. A voltmeter is always set up in parallel. So on this circuit here, what I do is I do a voltmeter outside of the circuit, and a voltmeter will go there like that. What is AC current and DC current? AC is alternating current, which means it goes backwards and forwards, approximately 50 odd times a second, right, in English electricity. And DC is direct current. Right, draw the current potential difference graphs of ohmic conductor, filament lamp and a diode. Alright, so I'll just draw the graphs first. I'm going to draw a cross, I'll draw a cross, I'll draw a cross. Okay, that side up there, that's amps, that's volts, that's amps, that's volts, that's amps, that's volts. Drawing the line, ohmic conductor, right, what an ohmic conductor is, it's basically a resistor, right, goes like that. Okay, and what that is directly proportional, which means it goes up the same amount as it goes across. A filament lamp is very similar, but what it does, it's kind of like an S shape. And it's an S shape, but it changes due to temperature. So as the temperature changes, the resistance changes. I'm just going to put here resistance. Okay, a diode. I hate drawing the diode one, so I'm going to have a go at doing it. What happens is it comes along here, because there's no flow at all, it gets to that point there and it goes wham, it goes up. Alright, so current in one direction only. Right, label the plug and write the colours of the 3 wires. Alright, so this one here is, let's do some colouring in, yay, colouring in yellow and green. And that one is earth. Okay, yellow and green. This one is then the blue. I'm not good at colouring on here. right? And the blue one is the neutral. Now, the last one, I haven't got brown, so what I'm going to do is I'm going to colour it there, right? And then what we'll do is we'll pretend that is brown, okay? And we will call that the live. Other things that are on there is we've also got the fuse, and we've kind of got the wire clamp. Question number 10, what is the frequency of the main supply in the UK? It is 50 Hertz. What is the potential difference of the main supply? 230 volts. Okay, so that's the stuff